All right, welcome back, everyone. We are going to finish chapter 3 today, so we're going to do part 3 and 4, both percentiles and quartiles. And we're going to start with, actually, what I want to do is I want to start with some definitions of things that we have already gone past, but I just want to make sure we understand the notation. X bar is the sample mean. Versus mu, which is the population mean. Then we have the S, which is the sample standard deviation, versus sigma, which you pronounce sigma. This is the population standard deviation. In addition to that, we have S squared, which is the sample variance, versus sigma squared, which is the population variance. So just some notations to keep in mind there. All right, let's start our percentile talk. We'll talk about starting with the z-score. A z-score is the number of standard deviations that a given value x is above or below the mean. The z-score is calculated, and these are our formulas, which is why I went through the notations again, just because we're using some of those. So there's the x minus x bar over s, meaning x minus the sample mean divided by the sample standard deviation. But if we have the population information, then it's going to be z equals x minus mu, that's the Greek letter mu for the population mean, divided by the population standard deviation. Either way, the formula is the same. This is the great equalizer, a z-score. So let's say that someone goes for a 5K run and someone else takes a test and gets a certain score on the test. Well, that's really hard to compare, but if you want to see who did better, you could just get all the information that you need and z-score both of them, and then you can see how many standard deviations away from the mean you were. Whoever was the highest was the furthest away from the standard deviation, assuming they were above the mean. And it would switch, but that would be a way to reconcile two totally different sets of numbers and then figure out who did better with what. And we'll have examples of those in a minute. Looking at this table here that we see, z is in the, or 0 z-score is in the middle, that's the mean. Standard deviation is 1, so each 1, 2, 3, those are the number of standard deviations away that we're going, or z values, or z-scores that we're going from the mean. And as we talked about in a previous video, you'll notice 2 standard deviations away, not so significant, meaning that's what we consider usual. And anything more than 2 standard deviations or less than negative 2 standard deviations is considered unusually low or unusually high. So let's z-score something with our example here. When Steve Jobs was CEO of Apple, he earned an annual salary of $1. So this in our formula is going to be our x. The CEOs of 50 largest US companies had a mean salary, and this mean salary is going to be the x bar, of $1,449,779, and a standard deviation of $527,651. So here is our S. Convert Steve Jobs' salary to a z-score and then answer, is it unusual or not? I think we can all agree that a $1 annual salary is very unusually low, but let's verify that with our z-scores. So we're going to take the x, which is the data point, that's his salary, minus the mean, which is the $1,449,779, all divided by standard deviation, which is 527,651. And let's see how his z-score turns out. So we're going to go 1 minus 1,449,779 divided by 527,651. And there we can see his z-score is a negative, of course. And it's because it's less than 2 standard deviations away, it's unusually low. So we would say a $1 salary is unusually low. All right. Some properties of z-scores. Z-scores are expressed as numbers with no units of measurement, meaning if the original data is in dollars, like it is in the example above, the z-score still has no unit. It's not in dollars, it's not in inches, it's not in anything. If an individual data value is less than the mean, then the z-score will be negative. And we witnessed that with the previous example. We can see the negative z-score. A negative z-score isn't bad. All it means is that whatever data point we were using is lower than the mean. So if we're in a room of people and the average height is 5'4", and someone is 5'3", they're going to have a negative z-score relative to that group. Again, it's not a bad thing. It just means that they're below the mean. A positive z-score is going to mean that that particular data point was above the mean. And let's do our example here. Finding a z-score for a given data value. DeAndre is in his first semester at a university and is taking a calculus course with large enrollment. He just took the first midterm exam and is nervous about his score. Among all the students in the course, the mean of the exam was 55 with a standard deviation of 7. So let's get his z-score. So z is going to be his score. He scored a 74 minus the mean, which was 55, divided by the standard deviation, which is 7. So 74 minus 55 divided divided by 7. And we can see his score is about, z-score is about 2.714. So his is actually unusually high. Meaning DeAndre did quite well in this relative to the rest of the class. Again, he's above 2 standard deviations. All right, let's move on to Goran. Is in his first semester at a certain university and is taking a calculus course with large enrollment. He just took his first midterm exam and is nervous about his score, which was a 63. Among all the students in the course, the mean on the exam was an 83 and standard deviation was 9. So it looks like Goran is below the standard deviation, or the mean. So let's find his z-score. So he scored a 63 out of the 83, which was the mean, with a standard deviation of 9. Let's see what we get here. 63 minus 83 divided by 9. So he did not do very well. So his score is unusually low. And I want to point out, part B actually is going to let us come to the conclusion. And the way ALEKS has this set up when you write in the score, even though it's a negative 2.22, we're going to write it as a positive. It tells you to do that. So we're going to write it as a positive value. So positive 2.2 standard deviations. And you're going to get 2 options here. And this is going to be either above or below. And in this case, he is below the mean. Yeah, poor Goran didn't do it nearly as well as DeAndre did. All right, let's move on to percentiles. All right, percentiles. are measures of location, and we write it as p sub 1, p sub 2, and so on up to p sub 99, which divide a set of data into 100 groups with about 1% of the values in each group. For example, the 25th percentile, denoted p sub 25, has at least 25% of the data values below it and about 75% of the data above it. That's not super accurate, but that's good enough for what we're doing. We have some notation here. N is the total number of values in the data set. K is the percentile meaning, that's the subscript. L is the locator that gives the position of the value. And P sub K is the percentile. Let's jump into an example. Get rid of all the rhetoric here. Here are the test scores for 15 students in Mr. P's class. Now, I've put this data into my list 1. You may need to pause the video so that you can put the data into your list. And I want to show you. So stat edit, there's my list 1, the 86, 76, and so on. So what I'm going to do is I'm going to sort my list. So I'm going to go stat sort A for ascending order, meaning smallest number down to the biggest, and L1. And let's take a look at our data again. So there it is in order. Now, it's important that our data is in order, and I want to show you why when we're doing percentile. So I'm going to rewrite it. 34, 47, 51, 58, 65, 67, 71, 76, 77, 82, 83, 84, 86, 87, and 88. All right, so now we have our data in order. You can always order them by hand, but that takes too long. And it's a little bit more accurate to do it this way. Okay, so the question here is, first of all, there are 15 students total. They say that in the problem. They say, what percentage of these test scores are less than 78? So let's mark off. So we're looking here. Less than 78. So how many scores are there? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 scores that are less than 78. So that means that we are going to have 9 out of the 15. This is going to give us a percent. 9 divided by 15. Meaning 60% of the data are below a 78 score. And we would write this as a percentile. So there is 60% of the data is below a score of 78. So over here would be your 60%. All right. Next up, government agencies keep data about the income distribution of the population. The Rivera family and Choi family live in a county with 5,000 families. The Rivera family's income is at the 33rd percentile, meaning 33% of the other families in that county have a lower income than the Rivera family. The Choi family's income is at the 26th percentile, meaning 26% of the families that live in this county make less than the Choi family. Part A. Which of the following must be true about the Rivera families and the Choi family's incomes? All right, so let's look at the first one. The Rivera family earns $7,000 more than the Choi family. No, we have absolutely no information on that. The Choi family earns $7,000 more than the Rivera family. Well, we don't have that information either. Both the Rivera family and the Choi family earn more than the median. Now, the median would be 50th percentile, meaning half the people. Both the Rivera family and the Choi family earn less than the median income. That's true. They're both below the 50th percentile. So that is going to be our answer there. Now, if one of them was above the 50th percentile, then they would be making more than half of the families in there, but they're both below the 50th percentile. Which of the following must be true about the Rivera family's income? First one, the Rivera family earns about 33% of the highest income. That's not true. 33% are below where they are. The Rivera family's income is at the top half of incomes. Now, that would need to be above the 50th percentile for that to be true. The Rivera family earns $33,000. No, that's not what that means. The Rivera family earns less than about 67% of families in their county. That's true. Because their percentile of 33 means that 33% of the residents earn less than they do, which means about 67% of the residents earn more than they do. And let's move on to section 3.4, which is about quartiles. Quartiles divide data sets into fourths. So basically what we're going to end up with here, and let me draw this out for us. So about here, here, and here. And we're going to end up with about 25% in each of these. And we're going to end up with what's called a 5-number summary. I'll show you how to do that in just a second. And the 5-number summary is labeled like this. We have a minimum value, meaning the smallest value. We have our first quartile. We have the median, which we talked about before. That's the middle number. We have the third quartile, and then we have the maximum value. And this is what's referred to as the 5-number summary. Now, I do want to point out that this means that Q sub 1 is P sub 25, the median is P sub 50, and Q sub 3 is P sub 75, because 75% of the data is below that location. And we have a few formulas to find the IQR. The interquartile range is what that's called. The lower fence, sometimes it's called the lower boundary. We'll talk more about that in a minute. Then we have the upper fence, or the upper boundary. All right, let's get to our first example here on quartiles. Here are 11 scores on a science test. Now, I have put this data into my list 2. And you can see 57, 58, and so on are in list 2. You may need to pause the video to put your data in so that you can try it. And we are going to find the 5-number summary. So we're looking for the minimum, Q sub 1, which is the lower quartile, the median, Q sub 3, which is the upper quartile, and the max. Now, very nicely, all I have to do is run one var stats. And it does all of this information for us. And if you remember how to get there, you hit stat. Up at the top, calculate. And one variable statistics. Mine is on list 2, second 2. You can load it into whichever list you want, just make sure that you're consistent. And you'll have to scroll down in your calculator. Mine is off to the side here. So my minimum is the 57. My first quartile is 60. My median is 76. Third quartile is 79. And the max is 91. And back in the old days, we had to organize all of our data in order, and then we had to find the median on our own, and then find the quartiles on our own, but we have technology, so we're not going to do that. All right, so to be clear, the answers that they're looking for is the median, which is 76, the lower quartile, which in this case is 60, and the upper quartile, which is 79. And I want to go through real quick and find the IQR. the interquartile range, which is q sub 3 minus q sub 1. And again, those formulas are all right there, which is 79 minus 60, which looks like it's 19. So there's our IQR, and our lower boundary or our lower fence is q sub 1 minus 1.5 times the IQR. Just so you know, that's where that is right there, the lower fence, which in this case is going to be 60 minus 1.5 times 19. So I'm getting 31.5. And for our upper fence, it's going to be Q3 plus 1.5 times the IQR, which is going to be 79 minus 1.5 times 19. So 79 plus, that should be plus 1.5 times 19, getting 107.5. And what that means for us eventually is that we're going to have a set of data, and we are going to have the lower fence, which in this case is 31.5, and we're going to have the upper fence, in this case is 107.5. And these fences are going to separate out for us that this data, so the data between 31.5 and 107.5, data is okay. Problem is when we're out here, this is an outlier. What we mean by that is, let's say that in the list of data that we ended up with, and by the way, there are no outliers on this, so let's take a look at list 2 again. So the lowest that I have is a 57, so we're above the 31.5, and the highest I have is a 91, which is below the 107.5. So all of my data is good. There are no outliers with this data. But let's say one of the data points was a 30. Well, that's below my lower fence. That 30 would be an outlier. Or I had a data point that was 110. You can see that's much bigger than my 107.5, so that would be considered an outlier as well. And we'll talk about what to do with outliers once we find them also. Let's keep going. All right, we're going to find the fine number summary for this and the IQR. Just to be clear, this data I've already put into my list 3. You may need to pause the video to put the data into your list 3. And you can see my list 3 as the 27, the 36, and so on. All right, so I'm going to run one var stats again, so I can get my minimum, Q1, median, Q3, and maximum. So here we go. Stat, calculate, one var stats. Mine is in list 3, second 3. And we can very nicely see our data. So this is 27, 36, 40, 46, and the maximum is at 56. They want us also to find the interquartile range. I'm not only going to find that, but I'm going to find, so IQR. Just for the practice, I'm going to find the others as well. So this is going to be the 46. Oh. 46 minus the 36. So my IQR is 10 in this case. And I'm going to go ahead and find my lower and upper fence. So lower fence is 36 minus 1.5 times 10. So 36 minus 1.5 times 10. So we're at 21. The upper fence is going to be 46 plus 1.5 times 10. That's 61. And I'm going to look back at my data in list 3, and I don't have any data that's below 21, and I don't have any data that is above 61. So in this case, there would be no outliers. All right. So here we go. We're going to use the IQR to find outliers in the data set. A bakery sells 11 types of sandwiches. Here are their calorie amounts. And you can see my list 4 is right here. Again, you may need to take some time to put some data in if you need to pause the video. Part A. So let's find the quartiles. In fact, I'm just going to list them here. So min, Q1, median, Q3, and the max. And I'm going to do this for my list 4. So stat, calculate one var stats. And this is going to be list 4. So I'm getting 592, 596, 599. Q3 is 602, and the max is 607. All right. All right, let's go back to our problem here. All right, we have Q1. Q1 is the 596. Q3 is the 602. The IQR, again, is Q3 minus Q1. So it's looking like, nope, I typed that in incorrectly. Let's do that again. 602 minus 596, better. All right, so I'm getting 6 as an answer, so 6. And now we're going to find the lower, they call them boundary, I call them fences, just depends on the textbook. So lower boundary, we'll call it. That's going to be Q1 596 minus 1.5 times 6. So 596 minus 1.5 times 6. And my upper boundary is going to be 602 plus 1.5 times 6. All right, so let's take a look at, so 587 and 611. And let's take a look at our data to see if we have any outliers. We're looking at list 4 here. And do we have any data below 587? Yes, we do. No, we don't. My mistake. So no outliers down there. And do we have any outliers above 611? We do not. So in this case, there are no outliers at all. Don't worry, we will eventually have outliers. Anyway, making a big deal out of this. And that brings us to our graphs called box plots. I always call them box and whisker diagrams. You can see the picture there, and you can see the whiskers and the boxes. I kind of think it's more of a fun name, but whatever. All right, so let's interpret this here. So it says each day for several weeks, a food bank recorded the number of people it served. The box and whisker plot summarizes the data. So here we are. And it looks like this is the minimum. In this case, we're at 85. Here we're at Q1, and it looks like we're at 92 down here. And the median, it looks like we're at 101. In Q3, we're at 110. And our max here is at 117. So 85, 92, 101, 110, and 117. And let's interpret this. What is the largest number of people served? Well, that is going to be a definitive 117. That's all the way at on the right there in our picture. What is the median number of people served? That's 101. And what is the first quartile of the numbers of people served? That is a 92. So once you mark up the graph, it's really not so bad. And now let's talk about graphing some data. And I have put this data into my L5. You may need to put this data into a list and pause the video to do so, which is fine. All right, now before I do this, I want to point out, it's going to give you a generic graph like this, and you're expected to, there's a tool that you're going to drag these values to wherever they need to go and move the median and move the Q3 and everything as we're doing this. I can't demonstrate that for you here, but when you get to it, you'll just drag and drop wherever these pieces are going to end up. First thing I'm going to do with my L5 is show it to you. Here's my L5, and you can see it has the 65 and the 73 and the 77 and so on. First thing I need to do is sort this. So I'm going to hit stat, and then sort A, and then this is my list 5, L5. And this way, when we're looking for outliers, it'll be really easy to see, do we have numbers below or above a certain point there. Okay, let's start up with our 5-number summary. Minimum, Q1, the median, Q3, and max. So I'm going to hit stat, calculate one var statistics. This is on list 5. And we can see that our minimum is 51. Q1 is 60. Median is 68. Q3 is 76, and our maximum is 85. And I'm actually going to draw this before we do that, let's find our IQR. It is going to be 76 minus 60. That's going to be 16. And our lower fence is the 60 minus 1.5 times the IQR, which is 16. See what we get. So I'm getting 36. And our upper fence is 76 plus 1.5 times 16. Comes out to be about 100. So let's take a look at our data in list 5. Do we have anything below 36? We do not. Anything above 100? Let's go to the bottom of the list. Oh, that is the bottom of the list. So no, in this case, no outliers. So we're going to actually draw this because I can't drag and drop those, unfortunately. Yeah, so we're going to go here. And I'm going to start here at 50, 60, 70, 80, and 90. And here we go. So I'm going to start with 51. Next up, we're at 60, and 68, 76, and 85. And then our whiskers are here. So it's not that hard to draw. Kind of cool. And finally, we're going to end up with some outliers on this last example. And we'll talk about what we're going to do with them. So I have put this data into my list 6. I'll show it to you. List 6, there it is. You can see 52, then 68, 43, and so on. All right. So these are below our noontime temperatures in degrees Fahrenheit of 20 world cities measured on the same day. So let's find our 5-number summary. And let's run stat calculate one var statistics on list 6. And here we are. We're at 37, 58.5, 66.5, 69.5, and 88. All right, let's find the IQR. Which is going to be 69.5 minus 58.5, which gives us exactly 11. Our lower fence is going to be 58.5 minus 1.5 times 11. Our upper fence is going to be 69.5 plus 1.5 times our IQR. So 58.5 minus 1.5 times 11. I'm getting 42. 69.5 plus 1.5 times 11. 86. So the question is, do we have any outliers? In fact, let me pull up the... So let's look, do we have any values that are less than 42? Let's go all the way to the top. Oh, I haven't sorted this yet. Let's sort this. So stat sort L6. There we go. Any values less than 42? Yes, we do. 37. So 37 is now out. And the next value I can see in my list there is 43. 43 is above the 42. Now, if 43 wasn't, then we would have to make it an outlier also. So our new minimum is now 43. And do we have any values? Let's go down to the bottom of the list that are less than 80, or bigger than 86. And yes, we do. So 88 is out. What's the next value down is 85. So things are going to change with this one. All right. So let's see what all of this means as far as our graph goes. So I'm going to start down here at 35. There we are. All right. So let's do so let's take care of the outliers first. So I'm going to go to 37, which is about here. I'm going to put an asterisk. I'm also going to go to 88, pardon me. 88. And put an asterisk. Meaning we're going to acknowledge that we have outliers, that they existed as part of our data, but we're not going to use it as part of our graph. So let's go to our actual graph now. So we're going to start at 43. Then 58.5. Then 66.5, 66.5. Then 69.5, that's way here, 69.5. And then 85 way out here. So here is our graph. And there is our modified box and whisker graph. I hope you found this helpful. Take care.